Getting started with our exam review for chapter 1. I got my video going now, you guys. The first answer is D, number 2 is A, number 3 is C, 4 is B, 5 is A, 6 is C. Now, are there any of those you want me to work out? All right, so quick like on number 1. Somebody said 1. I'm going to go over the ones that, somebody give me a hand here. What's happening? -6, -6, -6, -6. What's the next one? Take 6 away, 10. Anything else on this first page? Sure. The property that's illustrated. Oh, what I can see went on here is that the parentheses just moved. The parentheses were around the square root of 8 and 11, and the numbers are all the same. The parentheses just moved. They regrouped, and it has to do with addition. Why it went down here. C, associative property of addition. Associative means regrouping. And then you guys know distributive property, but associative means regrouping. So I could do the same thing on multiplication. And then just another little thing right here. Anything that I'm jotting down is just going to help you as a reminder. Commutative means stuff is switchable. That's not the answer to this one, but just something on that. Commutative means stuff is switchable. Like 2 plus 3 is the same as 3 plus 2. 2 times 3 is the same as 3 times 2. Moving on to the second page, I'll give you the letters and then we'll talk about anything you want to. Number 7 is C. 8 is A. 9 is A. 10 is C. Something tells me I should do 10, huh? 11 is B. And 12 is D. 11 is B. 12 is D. I'm going to give you guys 13 as well because that's the last multiple choice. 13 is C. Now, anybody want me to do 13 before I back up? Yes. 13 real quick. 2 plus 2k is less than or equal to 8. I'm going to take 2 away from both sides. 2k is less than or equal to 6. I'm going to divide by 2 on both sides. K is less than or equal to 3. There it is right there. And closed circle on 3. Everything to the left is shaded. So there's number 13. But let me back up. Do I need 7 or 8?
Yep. No.
8. 8. If the perimeter of a rectangle, I just talked about commutative and associative on the other page. This one wound up being C, switchable, so that's easy. If a perimeter of a rectangular picture frame must be less than 200 inches. So perimeter is when I add all the way around. So going all the way around, the first thing I'm thinking of is that 2 times the length plus 2 times the width is equal to perimeter. And they tell me that this has to be less than 200, so I'm actually going to write this differently. Has to be less than 200. If the width is 36 inches, what must the height of the frame be? Oh, okay. So width and height. I had length. I'm going to change this to H because they're talking about it in terms of height and width. So what they gave me is that the width is 36. So 2 times the height plus 2 times 36 has to be less than 200. So 2 times the height plus 72 has to be less than 200. So yep, it's just going through the process of solving. 2 times the height has to be less than, this is going to be 128 when I take away 72 from both sides. And so I took 72 away, and when I divide by 2, the height is less than 64. Height has got to be less than 64. So my problem was this. I plugged in 36 and then solved. Now in number 9, you'd actually have to solve it. I know that somebody's going to ask me about this. You'd have to go through the process of solving it, and in doing so, I'm going to distribute, and then I'm going to rewrite this over here as I distribute. So if I distribute here, let me just zoom in a little bit for you guys. If I distribute here 20x minus 10 minus 9x is less than or equal to 11x plus 13. Now this idea of always, sometimes, or never, if you go back into chapter 1 when you're solving these, it has to do with in the process of solving, okay, I'm talking and I'm working all at the same time. In the process of solving, if you wind up getting an x is less than, like you get an answer for x, it means one thing. Let's see what happens here. Ooh, if I take 11x's away from both sides, I get a true inequality. Negative 10x is less than or equal to 13. I get a true inequality with no value for x, and that is what leads to this idea of always. Sometimes and never. I want to give you guys a page in your book that you can go look this up in. So this idea of always, sometimes, never, just because it's always, and this is what we have on this test question, doesn't mean that's going to be how it works out on your exam. So the idea of always, sometimes, never, put in another hour's worth of work going back through some of these deals. That stuff comes up on no solution, always, sometimes, never. I'm looking at page 36 in your textbook that talks about the always, sometimes, never, and has some examples. Page 36 in your book. Jot that down so you can go back to it. What does it look like if it's sometimes or never? What does it look like if it's sometimes or never? We have an always example only. Now, solving this inequality, solving the inequality that has absolute value in it. And I want to get you guys a page number on this too, because I know some of you were already saying, like, I just didn't remember how to do this. And I really think, bless you, I really think that that you guys could get a lot out of just going back into your textbook and reading through some of these sections. The absolute value in equations and inequalities is in section 1.6, and it starts on page 41. And I'll jot that down there, but then I'm going to go ahead, of course, and work this problem out for you. What we're going to do when we have a situation like this with the inequality, we will be, and if you guys, I think you're going to kind of look at this and hopefully it'll ring a bell. This is greater than 23. So what we do in a greater than situation, what we're going to do is we're going to go and say that 2x plus 7 is greater than 23. We drop the signs. And we write it out just the way it is. 2x plus 7 is greater than 23. These absolute value signs going away lead me to something else, though. It's either 2x plus 7 is greater than 23, or 2x plus 7 is less than negative 23. Now, I'm looking specifically on pages 43 and 44 in your book. And I want you to just remember that absolute value asks you how far something is from 0 on a number line. And so since this is 23, that's why it stays here like this. But my negative 23 comes from, well, if it's the absolute value of negative 23, it's still 23. So you've got two problems to solve. And then once we solve them, we get back to 2x is less than, this would be 16. Finish this up, greater than, x is greater than 8. Take 7 away. 2x is less than negative 30. X is less than negative 15. There's my two inequalities, but they wanted it, yep. They've got to be, x is less than, there it is right there, that's my C. So here's the work that goes along with it, but it matched with letter C in the multiple choice. Just because stuff is multiple choice doesn't mean it's not a lot of work. Again, this was in section 1.6 in your book. In this example in particular, this stuff comes up on pages 43 and 44. Is there anything else in these multiple choice? Like these, I would just say go back and refresh your memory on all those number sets. Let me go on to the short answers for chapter 1. Why don't I give you guys the answers and then you'll see. You can tell me if you need me to work anything out. The answer to number 1 is 48. Number 2 is 21. Number 3, and you got to have work to all this. If you need to attach paper, even if you need to get up right now and get paper, you can. 1 through 4. There you go. Are there any of these that anyone wants me to work out? Justin, 2. All right, let me just do them all. Get up and get paper if you need to. And then you guys, if you have to attach paper with this when you go to turn it in, just put, if you got attached paper, make sure you title it. And I know I'm in the short answer part right now. They want me to solve this given that h equals -2. And so then anywhere I see an h, I'm going to put in -2. So 4 times 3 times -2 minus 6 all over 1 plus -2. So I'm putting -2 in where I see h's, and then I've got to go through and do the math. This is going to be -6 minus 6 all over -1. So my first move was to take 3 times -2, and then I just had that -6 there. I left my 4 outside because order of operations tells me I have to do everything in parentheses first. I'm going to come over here. 4 times -12 divided by -1. 4 times, 4 times -12 is -48. Divided by -1 is where I came up with +48. So plugging in -2 for h. That was in 2 places. Number 2, absolute value of 4b minus 4 plus the absolute value of 3 minus b squared plus 2 times b to the 3rd. They tell me to put in b equals 2. b equals 2. So the absolute value of 4 times 2 minus 4 plus absolute value of 3 minus 2 squared. I'm dropping that parentheses in there because this is subtraction out front of it, and I don't want there to be anything wonky happening with that. 2 times 2 to the 3rd. And then I'm going to just go underneath and I'm going to do all the little parts of the problem. So this is going to become the absolute value of 8 minus 4 plus the absolute value of 3 minus 4. 2 squared is 4 plus 2 times 8. 2 to the 3rd power is 8. You notice I have yet to pick up a calculator because the calculator is not going to do all these parts for me. So, you know, if I needed to, I could pick up the calculator for 2/3 or whatever, but you don't see me putting the whole equation into my calculator to solve it. Bless you. So now I'm down to the absolute value of 8 minus 4, so that's -4 inside, plus the absolute value of 3 minus 4, that's -1 inside, plus 16. The absolute value of -4 is 4. Absolute value of -1 is 1. Plus 16, that's where I came up with 21. 21? I'm sorry, that was stupid. Whatever. Number 3. You still see a couple pencils moving, so I'm going to wait a second here. All right, number 3, negative. I have a feeling on this one, if you didn't get -1, it probably had something to do with, you know, not using parentheses or, so this is -4x minus 4, and they're telling us to use x equals -3. Yep, I can anticipate your errors came from not dropping parentheses in places. So when I go put this in, I'm going to use the opposite of, and I'm putting, so I'm going to drop parentheses here, I'm going to drop parentheses here. The opposite of -3 to the 2nd power minus 4 times -3 minus 4. Now, this is going to wind up being -9 because -3 to the 2nd power is +9, but I still have this negative sign outside. This is -4 times -3. This is going to be -9 plus 12 is going to give me 3. 3 minus 4, that's where my -1 came from. But again, adding in parentheses and going into your calculator with parentheses. This one I actually think if the parentheses are in the right spots, you guys could get right from here to here with your calculator. Not as much going on as that absolute value one that we just did. Number 4, 5a plus 5b. A is -6. B is -5. 5 times -6 plus 5 times -5. -30 minus 25. Yeah, this one too. I'm comfortable right here just going straight to my calculator because you don't have all that other good stuff going on around it. Let me work out, let me go on from here and just work out the 5, 6, 7, 8, 9s. 5. These are solving literal equations. Our directions are to solve t equals 4u over e, and they want me to solve this for u, F-O-R-U, isolate u. Some of you guys were riding the struggle bus on these. If I'm going to get u alone, I've got to undo this divide by e on both sides. I'm going to multiply both sides by e. Undo divide by e by multiplying both sides by e. Et is equal to 4u. Focusing on the fact that I've got to get u alone because the problem says solve for u. Now I'm just going to divide everything by 4. And there's nothing I can do other than just writing this as u equals et over 4. Done. You could have it as te. Et means e times t. You could have it as t times e. It wouldn't make any difference because multiplication is commutative. Now for number 6, 7, this is just, you know, solving equations. Number 6, -5y minus 9. I would have to believe you guys have to have some kind of paper attached to this because there's not enough. Well, I guess you could work them out on the page there, but I couldn't. This is like distributing -1. -5y minus 9 equals -y plus 1. -1, -1 going through here. You can start solving these in many ways, but I'm going to choose to start by adding 5y's to both sides. Be careful with your negative. When I add 5y's, those go away. Make sure you don't lose that negative on its way down. 4y's plus 1. If I subtract 1 from both sides, -10 equals 4y. Divide both sides by 4. Y is -5/2, -2.5. Moving on to number 7, -2. Where am I? -2y minus 4 equals 8 minus y. I want you guys to notice that I purposely put a bunch of negatives in these problems because I know that's the place where sometimes this can get the ugliest. Adding 2y's to both sides. Watch for leaving these negatives behind. -4 equals 8 plus y. -y and 2y is just going to give me a y. Take 8 away. What? I picked up a pencil. Y is -12. I haven't stopped and asked if there was any questions in a few minutes. Is there anything that anybody wants me to go back to? Justin. Yeah, the U's and T's. Talk about that. What do you need? Yeah, it is confusing. It's just, you know, thinking about how if these were numbers, what would you do to undo? And do those same things on the variables. So like in the beginning when I started talking about this, I took my orange marker and I highlighted the U because I'm like, I got to undo everything around there. And so when I first looked at it, I thought, well, I've got this U sitting up top and I got to get this fraction out of here. This is saying divide by E. You know, if it was divide by 2, you'd probably go, oh, multiply by 2. You got to go along with that same line of thinking. So that's why I multiplied by 2 on both sides first, and it put me here. Still got E I'm still got u over here, and I got a 4 stuck to it, the operations multiplication. You know, if this was 29 equals 4u, you'd go, oh, divide by 4 to get it out of there. You still do the same thing. Is that a little bit better? Like, the process is the same as if you were doing it numerically. So you're undoing, like, your steps to undo aren't different. It's just on variables, not numbers. Other stuff besides that. 8. Oh, I'm sorry. Did somebody say another one? I'm going to go on to 8. I can come back if need be. -3, where am I? Times the quantity, -4y plus 3 plus 7y. Oh, this isn't even like solve. It's just combine like terms. So before I can even combine like terms, though, I've got to distribute. -3 times -4y is 12y. -3 times +3 is going to give me a -9. Then I got this 7y hanging out here, so 19y's minus 9. The like terms were the y's. 19y minus 9. And then number 9, last one. Okay, well, that was like the easiest problem in the world that dropped right there, huh?
Yeah.
Add 0.9 to both sides, x is 3.9. Add 0.9 to both sides, x is 3.9. Where did that weird little problem come from? Huh.